Hey everyone, welcome back. In this video, we'll be learning how we can write and analyze an algorithm. Let me just take the example of swapping two numbers. We are given A as 10, B as 20. Our output should be A should have 20, B should have 10. Now, how can we swap these two variables to get output as below? What we can do is, we have 10 here and 20 here. We can just take this 10 and store it separately in some variable. Let's take C. Now, update this value to 20 and update this to 10. In that way, two variables will be swapped. Let me just write down that. This is the algorithm. Swap of A comma B. And whenever we start an algorithm, we will start with begin keyword. And this is kind of a function. And inside swap of A comma B, we will be having a temp variable that takes in A value. Then A gets updated with B value. Then B gets the stored temp value. And after completing an algorithm, we will end that with end keyword. This is the function to swap two variables. Can we do it without using a third variable? This is just an extra thing. This is not related to analyzing an algorithm. I'm just telling for your knowledge purpose. Let's take, we have A as 10. I'll just take the same example, B as 20. Swap two variables without using third variable. In this case, what we can do is add these two variables and assign it to A plus B. This gives the output as 30. Now, we need to update B value using subtraction, A minus B. What is the value of A? 30. 30 minus B, B is 20. 30 minus 20, 10. Now we know second variable is being swapped. Now we need to swap the first variable. A equals, again same operation, A minus B, B is 10, A is 30, 30 minus 10, 20. After these three operations, we will end up with A as 20 and B as 10. This is how we can swap two variables without using a third variable. Now let us come back to our topic, analyzing an algorithm. As we have discussed in our previous video, how we can analyze an algorithm, meaning what are the ways that we can use to analyze an algorithm. One is time and the other is space. There are many other aspects which we can use to analyze an algorithm, but time and space are the mainly used aspects to analyze an algorithm. Let us see the time complexity of above swap algorithm. Time complexity of swap algorithm. Let me just repeat that function. Every simple statement in an algorithm takes 1 unit of time. Simple statement meaning calling a method, assigning variables, updating variables, and so on, but not the loops. We'll be studying the time complexity of loops in the next video. For now, let's see the time complexity of simple statements. Here, this is a simple statement where we are just updating a variable. This takes 1 unit of time. And this is again same, updating variables, 1 unit of time. Even third line takes the same 1 unit of time. After adding all three, we will end up with 3 unit of time. Therefore, this swap function f of n will represent the function using f of n takes 3 unit of time. Irrespective of the values of a and b. And these a and b could be anything, but it takes only 3 unit of time. In time complexity, whether it takes 3 unit of time or 30 unit of time, it doesn't matter if it is a finite unit of time. It will be considered as always constant time. And this constant time is represented as order of 1 or big O of 1. Don't worry about big O. We'll be covering these things in this playlist itself. For now, you can just consider this as upper bound of time. Now we can write time complexity of this function as order of 1. We got to know the time complexity for swap algorithm. Now let us analyze the space complexity of swap algorithm. I'll repeat the same function. To analyze the space complexity of an algorithm, we need to list down the variables that are used in that particular function. Let me just write down the variables that are used in swap function. We are using variable A, variable B, and temp. Variable A takes in one word of space. Variable B takes in one word of space. Temp variable will also take the same one word of space. Why we are using the keyword word here? Because while writing an algorithm, we never know its data type, right? So we are just generalizing these to word. After adding all these, we'll end up with using 3 word of space. We'll represent the space complexity as S of n. This takes 3 words. As we have just now discussed in time complexity, even in space complexity, if it takes finite unit of space, it is considered as constant space and represented using the same order of 1. Therefore, the space complexity of swap function is order of 1. That's it for this video. Just to reiterate, in this video we have learned how we can write an algorithm and what are all the ways that we use to analyze an algorithm. In that, time complexity is one of them. We have seen time complexity of swap function and the space complexity of swap function. In addition to these things, we have also seen how we can swap 2 variables without using the third variable. In the next coming video, we'll be seeing the frequency count method, which is nothing but analyzing the time and space complexity of loops. Thank you all for watching. See you in the next one.